All right, hi folks. So let's think about what our data means. So we timed the ball rolling. I didn't give it a push. I was careful, well, Matthew was careful to release it without giving it a push. So it started at rest here. And we timed the ball as it rolled down the inclined plane from the top. I stopped it at the exact middle of the board. And then we did it again where I didn't start the stopwatch until the ball was already rolling and reached the halfway point. I started the stopwatch here and I stopped the stopwatch when it fell off the board. And then we timed it as it rolled the whole way down the board the whole time. I'll get that. Okay, so that's how we collected our data. We did it when we only had half of the number of books. We did it with twice the number of books. So as we look at this data, I'm going to look at when the board was less steeply inclined with you guys, and then you all should already have a picture of the data, can do all the work again for when the board was more steeply inclined, and then include it all in the lab report. So I averaged 5 trials. Obviously, when you average 5 trials, it reduces the amount of human error because you can see, like if you look at the top half, I have some pretty consistent results. It looks like about 1.3 seconds for it to roll on the top half of the board. Then I've got this kind of really big number, maybe one that's a little smaller. So hopefully 5 trials will reduce my error. 10 trials would be better, 100 trials would be yet better, but obviously we don't have time for that. So I averaged that. So if we look here, it took 1.40 seconds, sig fig wise. Since all my times are out to the 100th place, I kept to the 100th place for the average. That gives us 3 sig figs here and here, but only 2 sig figs for the bottom half of the board because it was less than a second. So, and then put units here. Units are important to us. I can't actually write while filming. We'll just put S. I can't do this. Okay, so for the top half of the board, it took 1.40 seconds. For the bottom half of the board, 0.81 seconds. And for the whole board, 2.37 seconds. If we added these guys up, 1.4 and 1.8, what would that be? That would be 2.2 seconds, which makes at least some sense, I guess. You can see, obviously, we have sources of error, like my reflexes starting and stopping the stopwatch. That would be the big one. Also, we have friction and air resistance that we're not accounting for when we think about velocity, but that's okay because we're really just trying to measure the actual velocity, not the like frictionless velocity. So that should be fine. So what is velocity? So first thing is velocity is a vector quantity. So we have to consider displacement and not distance. And so displacement is just the amount of distance that's covered from the exact start to the exact end of the path. So we're like a straight line from beginning to end. So even if the ball kind of weaves all over the board, as long as we get kind of a straight path from here to here, that's fine. And so we're just assuming that the full length measurement of the board is the displacement, even if the ball hits this knot and kind of wanders around the board. Also, we have to report direction. So in your lab report, your velocity should have direction. So we've got displacements measured. I wrote them here. I measured the whole board with my handy dandy auto measurer because all the yardsticks are still at church, to be 1.222 meters. And then I cut the board in half, hopefully accurately. It was really bad. This is not one of your boards. It was cut like not nearly in half when I checked. So that's interesting for last year's data. So the whole board, for example, we want displacement over time. So velocity equals displacement over time. And that would be, it went 1.222 meters in 2.37 seconds. Oh, well, since I use my, well, hold on, I think I can pause.